Okay, year seven. We're now going to move on to something which you may or may not have heard of before. You may have heard of before, or you may not be entirely sure where it came from. So we're now going to talk about, well, up until now, we've been finding the perimeter of straight-sided shapes. Now, in our world, there are lots of curved shapes, and the most common curve that we see is a circle. Most of the stuff we see around ourselves is circles. Different planets are spherical, orbital paths are pretty close to spherical, they're elliptical, which is pretty close to a circle, depends upon how wide it is. So all those sorts of things. Now, for many civilizations have come to understand pi, but we're going to talk about Archimedes. And I've put a video from YouTube up on how he actually did it, but it's quite interesting. So if we think about it, and I'm just going to get a circle up here. If I want to find the distance of a circle, and that one doesn't even look like a circle, it looks a bit, anyway. If I want to find the distance, I can't measure it because it's a curved shape. But what if I put a square around this circle? And that's a really bad line, that last one. So I'm trying to get the square to fit exactly in it. And then I drew another square inside. Well, I can measure the distance of the square inside and measure the distance of the square outside, and that'll give me a good approximation of the circumference of a circle. By the way, the circumference is what we call the distance around the outside of a circle. Well, that's what Pythagoras did, but he just didn't stop at a square. What Pythagoras did is he said, righto, I'm going to draw a hexagon. And I've done a very bad job of drawing this hexagon. So you get a hexagon on the inside. And then he drew a hexagon on the outside. Then he drew a hexagon on the inside. Got it across there. That last one's pretty dodgy. But then he didn't stop there. He went even further. So he said, all right, what if I drew a dodecagon inside? And if I split all these into two. Oops. And then he said, oh, why not stop there? And he did the same on the outside. And he then said, oh, what if I did it again? So he started with a hexagon and he went 6. And then he doubled each side. He went 12. And then he doubled again, 24. And again, 48. And then he got a 96-sided shape, both on the inside and outside. And what did he discover? Well, he discovered that because all circles are just bigger or smaller versions of the same thing, that the ratio of the circumference, and the circumference is the distance around the outside, so the circumference is this distance around the outside, the ratio of the circumference, and remember we can write a ratio as a fraction, circumference to the diameter was always the same. It didn't matter how big or small the circle. The ratio of the circumference to the diameter was always the same. It didn't matter because all circles are similar. They're just bigger versions. And he discovered that that ratio was 3.14 because he could measure, and he got pretty close, measure the distance of circles by doing I don't even know what a 96-sided shape would be called, but starting with a hexagon inside and out. Now, he gave this symbol or this ratio a name. He used a Greek letter to represent it, which was pi, which looks like that, and pi equals 3.14. Now, on your calculator, you have pi, and you can see it's underneath the 3 button. And what you have to do, you have to press Shift. So you have to press Shift and that, and you get pi. And there you can see, and if you press equals, there it is. Now, we've got better calculations now. Archimedes got it to 3.14, but he had it as a fraction because he didn't have decimals, and he had 22/7. That's what he got it equal to. And that was Archimedes. Now, other civilizations also did this. The Egyptians knew pi. Look at this. The Egyptians knew pi. Their approximation was that. The Babylonians used 25/8. The Indians used that. Archimedes, all right, 22/7, there he is. And then the Chinese, this Chinese mathematician, he was able, or they were able to show that fraction. But before we had calculators, this 22/7 was what was commonly used. Now, we need to do, or understand a few things about what we talk about when we talk about a circle. So, what I want you to do is I want you to draw these 2 diagrams in your book, and I want you to label them. Now, you don't have to write what each of these things are, as long as you've got the diagram and it's labelled. So, for example, the diameter, it's a line that goes through side to side while passing through the centre. The radius, it's a line from the centre of the circle to the circumference. And the circumference is all the way around. And then we have some other things. If we draw a line from one side to the other that's not through the centre, well, it's called a chord. And it breaks up the circle into 2 segments. And you have the minor segment and the major segment, the major being the bigger. If you cut a piece of a circle, like a piece of cake, using the centre, using the radius, you get a sector. And a tangent is a line that goes and just touches the side of a circle. So I want you to take a couple of minutes, draw those 2 diagrams in your book, use a nice circle. If you've got a coin, use one of them. A 20-cent coin would be a good one, and nice and big. But if you've got a 10-cent coin, and draw those, and then use a ruler to do all those other little bits and label it. Once you've done that, come back and let's have a look at how we do these questions. Okay, so now that you're back and you've done those questions, this is really, really easy. So circumference, remember, pi equals the circumference over the diameter. Now, we haven't done equations yet. So usually we would have done equations before this, but what that means is I can rewrite this lovely little ratio that Archimedes and other civilizations gave us, and I can swap that d and that pi, and I can get the circumference equals pi times the diameter. I can find, because the ratio of the circumference to the diameter is always going to be 3.14, I can multiply 3.14 times the diameter, and it will tell me the circumference of any circle. So I want you to write that rule in your book. It is how you're going to find the circumference of a circle. Now, all we have to do are question 6, 9, 10, 15, and 17. So here we go. You don't need to write or draw the diagram. You can if you wish. So 6. Now I'm going to go 6a. Now remember, circumference equals pi times the diameter. And if I look at the very first question, they don't give me the diameter. They only give me the radius. But remember, the diameter goes all the way to the other side. So if this distance is 2, then this distance is also 2. Also, if they give you the radius, you just need to double it. So, please don't go back to the beginning. And it has, it's gone back to rectilinear. Right. So here we go back here to this question. So, it equals pi times 4 because the diameter is double the radius. Okay, you need your calculators for this. So, and once you type it into your calculator, so what I want you to do, clear it, go shift, hold on, I'm going to do it with my arrow rather than my, shift, pi, times, and you put in the number 4, and you get your answer. Now they want the answer to 2 decimal places, so I always write more, so it was 12.566 ... And remember, we learnt rounding. We go to there, and we look at the answer and go, 12.5. This number is 6 or bigger than 5, so make that a 7. So 12.57, and what units were we in? Millimetres. Well, let's do B. Let's have a look at B. Circumference equals pi times the diameter. Again, they haven't given us the diameter, but we already know that the rest of the way will be another 18. And 2 times 18 is 36. So the circumference is pi times 36. Now, if I go to my calculator, I don't need to go back and type the whole thing in again. I can just use this back arrow. It takes me back into there, and I can delete the 4 and type in 36. I don't have to keep going in, typing it. 113.097. 113.097 ... A whole lot more. But we're only going to 2 decimal places, so we draw our line down there, and we get 113 point... that 7's going to round that 9 up to 10. So I have to write the 1 and the 0, and it's metres. Okay, now let's have a go at, you can do C on your own. I'm going to go to D because these are terribly easy. These ones are actually easier. Pi times diameter. And here it's pi. And guess what? The diameter is 4. Well, it's exactly the same as the one above. 12.57, but this time it's in metres. Let's have a go at E. Circumference equals pi times diameter. And the diameter is 7. So pi times 7. Again, I go to my calculator. I use my back arrow so I don't have to retype it all in. And I get rid of the 36 and I put in 7. And I get 21.991. 21.991. There are a whole lot of other numbers, but I only have to go to there because we're going to 2 decimal places. I'll draw that line down there and I go, the number behind is less than 5, so I do not do any rounding. And what units was it in? Kilometres. So they're pretty easy. The circumference is pi times the diameter. And we got that because different civilizations were able to calculate that the ratio of the circumference over the diameter in any circle is 3.14 or thereabouts. Now, question 9. A water tank, so you can see a water tank, the cylindrical water tank, has a diameter of 3.5 metres. Find its circumference. Well, that's easy. So here's 9. Circumference is pi times diameter. So I'm just finding how far around. What's the circumference of the base? The diameter is 3.5. And they want me to find it to 1 decimal place. So I'll pull out my calculator. Again, I just use my back arrow. I delete the 7 and I put in 3.5. I get 10.99. Now remember, I'm only going to 1 decimal place. 10.99 and then a whole lot of more decimals. I go to here. I draw the line down there and I go, that 9, well, I'll have to round up, which makes that 9 a 10. So it's going to be 11.0 metres. You must put in the 0. And question 10. You have a go at it on your own before I have a go at it. So an athlete is running on a circular track that has a radius of 40 metres. So I'm going to draw this just to make it easier. So here's this athlete. And they're on a circular track and the radius is 40 metres. They do 10 laps each day for 5 days. How far have they run? Okay, well, I need to work out the circumference. So the circumference equals pi times diameter. Well, that's going to be pi times 80. Now, I'm not going to do that calculation yet. And by the way, I hope you know how I got 80. I just did 2 times 40 equals 80. Because that'll tell me the circumference, but I only want to do one calculation on my calculator. So how far do they run? So they run around this track. So I've got my pi times 80. And they run around that track 10 times a day for 5 days. So I'm going to do the whole calculation in one go. So let's double check it. Runs 10 laps a day for 5 days in a week. So the circumference of the circle, pi times 80, 10 laps, times it by 10, 5 days. So I go to my calculator. I use my back arrow. Pi times 80, times it by 10, and then times it by 5. And that's how many metres they've run. So what was it again? 12566, 12566.37061. Well, what did the question ask? Round the answer to the nearest whole number of metres. So I'm stopping at the decimal point. So I write 1, 2, 5, 6. Now, is the number behind 5 or more? No. So I leave it alone. 12566 metres. Now, the last 2 questions that I want you to do, 15 and 17. This is an interesting one. And I'm just going to use some maths to do this. So you don't have to write a big sentence. Circumference equals pi times diameter. We know that. But we know, and we did it up here, that the diameter is 2 times the radius. So therefore, I love this little symbol, 3 dots in a triangle mean therefore, the circumference equals pi times, and we said the diameter is equal to 2 times the radius. Now, what are we trying to say? That it's the same as 2 pi r. Well, we know when we multiply things, remember pi is a number, pi is 3.14, it doesn't matter what order we multiply. So we can say 2 times pi times r. And when we write algebra, we already know you do not need the multiplication symbols. So 2 pi r is also the circumference. Therefore, pi d is the same as 2 pi r. And there we go. Now, you can have a go at 17, but I would rather, if you want to, just do 17b. All right? But it's just using this equation. Now, make sure you finish questions 6, 9, 10, and now you've seen how to do 15.